Unusual parachute openings happen to all skydivers from time to time. There are several common problems that can occur but can easily be fixed. These are not generally considered to be malfunctions, but are normal opening quirks of ram air parachutes. These scenarios are covered in this section and will also be reviewed when discussing flight characteristics of the main parachute. Try to keep in mind that in all likelihood, each of you will experience a normal open main parachute and an uneventful landing on your jump today. However, we must always learn, practice, and prepare to deal with a malfunction on every skydive. A pilot chute can sometimes come back under the front of a fully inflated parachute after the opening sequence. At times it will snag or rest in the lines under the canopy. This can also occur after a radical stall maneuver is done intentionally by a skydiver. Therefore, a radical stall is probably best avoided even when doing your controllability check. Stalls are discussed at greater length later in this video. As you can see in this case, the pilot chute's location is not causing any problem since the parachute is rectangular in shape, flying straight, and is controllable. Only in rare cases would having a pilot chute under the main canopy make it uncontrollable. Line twists are a common occurrence, and probably 25% of you will have some on your first few jumps. They also will occur from time to time during your skydiving career. Fortunately, they are not a big problem and are easily remedied. Line twists are usually caused by air currents twisting the bag which contains your parachute during the deployment sequence. Line twists do sometimes just happen, but they are more commonly caused or made worse by a poor body position. Try to imagine the deployment bag launching from a flat, stable surface like this table. It most likely will come off straight and even. If that surface were slanted or moving around, the bag will not launch level. At first, the line twists make it seem difficult to get your parachute under control. After a few seconds of untwisting, the parachute can be easily controlled and will be flying normally. Think of untwisting the lines as untwisting the chains on a swing of a schoolyard swing set. If you grab your risers and spread them apart and kick in the direction that is opposite the twist, the line's twists will come out in virtually all circumstances. This parachute had many line twists, which is much more than normally experienced. Still, it only took a bit of effort to deal with them and end up with a fully functional parachute. Rarely are line twists a reason for a cutaway, and even severe line twists can usually be fixed in less than 1 minute. If for some reason the line twists will not come out by 2,500 feet, you should begin your emergency procedures. It is possible that there is something else wrong. Going any further trying to fix the line twists may cause you to end up too close to the ground for a safe and uneventful cutaway. Another common occurrence is a situation where the slider has come down far enough that it is not causing a malfunction, but it has not come all the way down the lines. Often it appears to the skydiver to be 1/2 to 2/3 of the way down the lines. This is easily dealt with during a controllability check using the steering toggles. Simply release your brakes and pump them several times smoothly to the number 3 full brake position, and the slider will continue down to its resting position where the lines meet the risers. At times, this may have to be repeated. If the slider has not come to a resting point that is closer to the suspended skydiver than to the inflated canopy, it is probable that there is some other problem. This decision, like all others, needs to be made by 2,500 feet. End cell closure will usually happen during deployment, but it can also occur during a turn, a stall, or during air turbulence. This is also easily corrected. As you can see, this parachute is not spinning and is controllable even with the end cells closed. Parachutes usually will continue to fly straight or turn only slightly if the closed end cells occur on one side. The cure for this is the same as the cure for the slider resting only halfway down the lines. Simply release your brakes and pump them several times smoothly to the number 3 full brake position. On a modern 9-cell canopy, A safe landing can still be made with 7 of the 9 cells open. However, it is important to follow the procedure to open all 9 cells because it is always better to land with a fully inflated parachute. An important sequence to follow is to check the canopy from top to bottom, then make corrections from bottom to top. In doing so, you will first make sure that the canopy is open and properly deployed. Then, if you have line twists, they can be kicked out, or if your slider is hung up, it can be pumped down. Finally, end cell closure can be dealt with. A controllability check is done after the parachute is open to ensure that it will fly straight, perform turns, and flare properly for landing. To do this, release the brakes, perform a 360-degree right turn, then a 360-degree left turn. Follow this with a practice flare, going from full flight to the number 3 full brake position, and then let the toggles back up smoothly. During this check, the parachute should remain stable, steerable, and square. It should also be fully inflated, intact, and under control by the canopy pilot.